Hello, welcome back to Computer Science 4303. Today is lecture number 3, so we will be talking about Visual Studio and Assignment 1. And so in this class, we will be using C++ for our 3 assignments. The StarCraft project will be using C++, even though other language support exists for the StarCraft BW API programming. We will only be using C++ in this course for that. And due to the Minecraft project being a little bit different, it will probably be done in Python, but you are free to use any language that you can get working for the Minecraft project. So, today is Thursday. We are looking at Visual Studio and Assignment 1. Now, what I have done for this class is I have a virtual machine. Please work. Yay, it works. Okay. So, of course, my actual machine that I use all the time is already set up for using Visual Studio and SFML, which is the library that we'll be using. And so what I did was I set up this little virtual machine here that you are now looking at, which doesn't have those things set up, so that we can do a setup video. And so if these instructions are a little bit unclear as to how you would go about setting up C++ and Visual Studio, then these instructions hopefully will make that a little bit clear. So in order to access these instructions, you can go to the teaching part of my website, and you come down here to the Google spreadsheet for 4303, and then there is an environment setup link. And so that will take you to a text file, which I already have open right here. So there we go. So just make sure someone say something out in the chat if I'm coming through loud and clear with the voice, because usually someone says something but no one said anything yet. So hopefully the stream is going well. Okay. So I have Linux instructions for this. I have Mac instructions for this. Okay, perfect. We are good to go. I have Mac M1 instructions for this. And I have Windows instruction for this. So I am not going to go show you the Linux or Mac instructions, because I do not have Linux or Mac available to show you in this sort of setup that I have. However, the Linux instructions are dead easy. The Mac instructions are pretty easy, and it's the Windows instructions that take the most time, and so that's what I'm going to be going through with you in this lecture. So a couple of quick links. First, I know this font is a little bit small. Let me see if I can increase that just a little bit here. Here we go. This should be all right. All right. So you've got the link to SFML. So if I take this over here and I copy and paste it, this will take you to the Simple and Fast Multimedia Library. That is the drawing library that we'll be using for C++. The reason I chose SFML is because it is by far the easiest and easiest to get set up and running of all the C++ libraries. You know, you have things like raw OpenGL. That's a nightmare. We would be spending half the course just teaching you how to draw a square in OpenGL if we were doing that. You have things like SDL, which are great, but they're a little bit too verbose for this, and so I've used SFML for that. So here's where you would download SFML. It's the 64-bit version up here in the top right. That's going to be the most recent version. There are some tutorials for SFML. If you want, I have lectures recorded for my Computer Science 4300 course. I've already told you how to get involved with that, or how to not get involved with, but how to see those. So there's an SFML tutorial there. There's also one on the website. And SFML has included official Mac instructions, which are here, but that teaches you how to get stuff up and running with Xcode, which is a little bit more difficult than the Mac instructions that I've included here. So please only use these Mac instructions as like a last resort. I have different Mac instructions down here, which I'll show you. Alrighty, so first we have the Linux instructions. It is very, very, very simple to get up and running with Linux. So you're just going to install GCC, which is the GNU C compiler, GCC, and also the SFML library on your system. So if you're using Ubuntu, something that uses apt as the package manager, then you can just say sudo apt-get install. G++. So G++ is the GNU C++ compiler. Build Essential. This gives you access to use the make files that I've included with the assignment. And libsfml-dev, that gives you access to the SFML libraries. So this is basically all that you need to type. There you go. Then you download and extract the assignment zip file. By the end of this evening, you will receive an email at your mun.ca email address containing links to download the assignments. Then you navigate to the assignment root directory. You use G++ to compile the program. So you can either type this one-liner into the command line to compile your entire project, or you can use the make file that I'm providing by just typing make, okay? And then make will build and run your project. So whichever one of these you do, that will place the executable called SFML game inside the bin folder. So then you change directory into the bin folder by typing cd bin, and you run the game by typing /SFML game, or whatever the executable you ended up using was. So that's it. Like Linux instructions for this are just like Linux instructions for anything else. You install the libraries with a simple command, you download and extract your zip file, you run whichever compile command you want, and then you run your program. You had a question out there. Would you recommend using a full-fledged IDE like CLion for the assignments? So what I am recommending is if you are using Windows for these assignments, please, for the love of God, use Visual Studio, okay? So Visual Studio is like the official Microsoft C++ full-fledged IDE and compiler that is released for Windows. So just use that, because the assignments you'll be getting are Visual Studio project files, so you'll just be able to double-click and use it. If you are using Linux or Mac, all you have to do is open the C++ files and edit them in literally any text editor, okay? So, because of that, what I recommend is VS Code. So the unfortunate thing is that Microsoft has named two of its completely different products very, very similar names. So there is Visual Studio. Visual Studio is the huge IDE with a built-in C++ compiler for Windows. Okay. Also, a version exists for Mac, but don't use that version. Apparently, it doesn't work very well. Then, the second product they have is called Visual Studio Code. Completely different program. So one is Visual Studio, one is Visual Studio Code, but fortunately, they've been marketing it as VS Code. So VS Code is essentially a glorified scriptable text editor. And I really like it. It's really well done. And in fact, if you go to my website and you go to the course spreadsheet, Google Sheet here, I actually have a tutorial on how to set up VS Code with C++ and Make. So if you are not going to use Windows, I highly recommend using VS Code. You can use whatever IDE that you can get running, but that's what I recommend, okay, is VS Code. Just a recommendation, not a requirement, but it is a requirement to do it with Visual Studio if you're on Windows. So for the Mac instructions, here are the very simple instructions. So you need to brew install SFML. So you may, depending on which version of your Mac OS X you have installed, you may have to install brew. I'm not sure which versions require that. So you brew install SFML, and then you follow the Linux instructions starting at step 1. Okay? So this is how you would go about on a Mac. So Mac and Linux are very, very similar. You may also have to install G++ and build essential, but you brew install SFML, and as long as you have G++, the GNU C compiler, and make installed, then you should be good to go. All right? And this worked with the Clang compiler, so you can use Clang as well, and I've included some other details here. Now, if you have a Mac M1 or M2, on some Mac M1 machines, brew installed libraries don't get added to the machine's path variable, so they're not found when you compile by default. So when you brew install on a Mac M1, depending on some weird version you might have, the computer doesn't automatically know where it installed SFML. So what you will kind of have to do, which is a bit annoying, but you're the one who bought the M1 Mac, you will have to find exactly where these libraries have been installed. So for example, for some people, it was in this folder. For some people, it was in like your home directory / homebrew, right? So you have to just find where those are. So you'd find the SFML directory somehow using some find command in the terminal, or you'd browse around and then you find that. And then you can manually add that directory into the compilation command by adding the following two options at the end of your compiler command. So what you have to do is you have to tell your compiler to include the SFML libraries with the -I and then that folder /include. So this is that folder up here, but with include at the end. And then you have to tell the C++ linker where to find the lib files. And so it's -L with no space and then the directory /lib. Once you're given a makefile in assignment 2, you can simply add that directory to the makefile in SFML-dir as SFML-dir variable, and it should work properly. So that is Linux, Mac, and Windows. Very, very easy to set up. You shouldn't have a lot of problems. The only problem should be maybe Mac M1 instructions. And then, as I said before, these in Mac instructions up here are far more complicated and teach you how to use Xcode. And if you choose to use Xcode, I will not be supporting you in that adventure, okay? Because I don't know how to use Xcode. I don't know how to set it up. All right. Next, the final set of instructions is the Windows instructions. And so what I will be doing is going through these step by step. I have not tested this yet. And so if something breaks, that will actually be a good thing because then we can fix it live on stream. So the first thing you have to do, and the only thing that I have done so far, is install Visual Studio 2022. Okay, so what you would do is you would say Visual Studio 2022. You would Google that. You would click this link here. You see, oh look, Visual Studio 2022, download, and then Community. Community is the free edition, and it is by far, it has way more features than we will need for this course. So you will not need Enterprise or Professional for this course. You just need Community. The only additional step that you may find is that it may ask you to sign into your Microsoft account. Okay, that's it. I think you may be able to get away with not signing into a Microsoft account, but that's it, right? You should probably have a Microsoft account if you're using Windows anyway. So when you go through the installer, it's very important. There's a box. There's a bunch of different options. There's maybe 20 different options when you go to install Visual Studio, because you could be using it for like .NET, C#, all sorts of different stuff. All you should install for this course is desktop development with C++. That will install all of the C++ libraries. So you click that, then you click next, and you click install, and half an hour later, it'll be ready to go, okay? And so please keep in mind, I get people asking me on the day that the assignment is due, why don't I have a compiler? Why isn't this running? It's because they tried to use VS Code or Visual Studio Code. It is not VS Code. It is Microsoft Visual Studio 2022 Community Edition. That is what we are using for this course. All right. Next, you have to install that 64-bit version of SFML. So at the time of recording, this file, this link right here works. So this is the exact zip file you will download. So just download that zip file. I have already downloaded that zip file just in case I had any internet troubles. So over here, I see that I have SFML-2.5.1-Windows, blah, blah, blah. That is the version that I want. And so what you have to do is extract that zip file to a folder on your computer that contains no spaces. This is a little bit annoying, but Microsoft and its infinite wisdom with environment variables, there can be an issue with that if you have spaces in your directory name. So what I said is I highly recommend creating a folder called C libraries, which is just directly under your C drive, so it's very easy to get to, and extracting the libraries there. So that should result in something like C libraries SFML-2.5.1, and that is where your SFML libraries are going to reside. And then later on, when you go to do the StarCraft project, we're going to put all the StarCraft files into that directory as well. So let's open up this zip file that we have here. Of course, I am using the free version of WinRAR, as you should. And then I'm going to go to my C drive. I have already created this directory called libraries, so I'm going to double click on that. And then I'm just going to take this folder and I'm going to drag it over here into libraries. That's it. SFML is now extracted. Okay, that's all you have to do. Pretty easy. The only real remaining instruction to set up SFML is to create 2 Windows environment variables. All right, so those Windows environment variables are going to be, there are 2 of them and they are used for 2 slightly different purposes. One of them is used by Visual Studio so that Visual Studio knows where the SFML libraries are. So when it goes to compile, it knows where those libraries are. And the second variable is used by Windows to know where the DLL files are, so that those are the dynamically linked libraries that when you run a program have to be present. And so you have to set up these 2 variables, and we'll do that right now. So on the Start menu, you're going to click the Start menu and you're going to type env. So env, and then we're going to say either edit the system environment variables or edit the environment variables for your account. Doesn't really matter which one it is. So I'm just going to click edit the system variables. So we get this window here, and then we are going to click environment variables down here. So we click environment variables. Here are the environment variables for my computer. So these are a bunch of different variables. You can see I have one for BW API. We'll talk about that later when we get into StarCraft stuff. So what you're going to do here, I already have this set up, but what I'm going to do is I'm going to delete that because I'm doing all this from scratch. And then you're going to click new. So you click new environment variable, and the variable name is going to be called SFML_dir. And then the value is, you can come over here to where you have SFML installed, and then you can right click, copy address as text, and then paste it into there. That's the way to make sure you have no typos. Okay. Then you're going to click OK, and then you're done. So that is OK. That is okay. So that's step D completed up to here. So that is the environment variable where Visual Studio knows where to find all of those library files. And so in Visual Studio, you're going to have a variable called SFML_dir, and that's going to read from the environment variables. Next is the way to show where Windows should look for those DLL files. And so what you have to do for that is edit your path variable. So in Windows, the path variable is where you put all your executables and stuff, so that if you type it in the terminal, you know where those things are. So what you're going to do now is after you have finished your SFML variable, you're going to click on the path variable and then hit edit. And then down here, you are going to type this. Okay, so you may have to type, so okay, let me delete that one. I'm going to come down here and I'm going to type new, and it'll allow me to type down here. So it'll say type this SFML_dir/bin. So what these percentage sign means is that is sort of, in some places you might have seen like a $sign to reference variables in like a Mac or Linux, but this is going to be how Windows does it, is with these percentage signs. And then when you're done that, you click OK. Now, those steps may not work if the environment variable has spaces in it. So if this directory, and now you click OK over here and then OK. So if this folder over here, C libraries SFML, if you put that in a folder that had spaces in it, that might not work. Okay. So I had a question here. Someone said, I already installed Visual Studio. I installed desktop development with C++, but I also installed everything else that said C++. That won't cause any problems, will it? The only problem that should cause is that it will eat up a ton more hard drive space. Okay, so you should be fine. I can't guarantee you'll be fine, but you should be fine, but it will involve a lot more download time and a lot more hard drive space. So at this point, if you had Visual Studio open, you now need to close it and open it again. Okay? And your computer, after you install Visual Studio, may have asked you to restart the computer, so you probably don't have Visual Studio open at this point. But just realize that Visual Studio reads the environment variables when it starts up. So if you ever make any change to an environment variable, you have to restart Visual Studio. The next thing is to download and extract the assignment zip file. So I have already done that over here. You do not have access to the assignment at the time of me saying this live at 10:50 a.m. But by the time you watch this later, so by midnight tonight, you will have gotten a link with the zip files. When you get the link for the zip file, if you're using Mun's email service, if you just try and click the link, I think because it's a zip file that contains like an exe in it, some browsers might think that's a security risk. And so just make sure you dismiss all the security risks. It's fine. And you may have to actually copy that link, open a new tab, and paste the link into a new tab in order to get the download to work. I don't know why that is. It's something to do with Mun's mail system, but just copy the link, paste it into a new tab, and you should be good to go if clicking it doesn't work. So I have the zip file here, and now it says extract that. So I'm going to right click and extract it to COMP4303_A1. So now I have a folder with all the files in it. So you can see here that there are many files that come with this assignment. I'll be going over those in a bit. I just want to go through and finish these instructions first. So what you do is you navigate to the Visual Studio folder. So you double click on that. There are a number of files in here. One of them is a solution file. So the solution files in Visual Studio are sort of like, I was going to say they're like the project files, but in Visual Studio, solutions are the main file, and solutions can include many project files. Okay, so for our course, actually not for the course, because so when we get to StarCraft, we will start to see multiple project files in a solution file, but for the assignments, every solution file will contain a single project. So what you do is, this says double click SFML game.sln. That is an old instruction. This is a1_tron.sln. So we are going to double click that to open up Visual Studio. Like I said, I haven't tested this yet, so we will debug it live if it happens. This is a virtual machine, so it may be a little bit slow opening Visual Studio. Okay, there we go. It is opening. Now, when you first launch Visual Studio for the first time, you may actually get some dialog boxes that you have to click or whatever. Just go through that little initial setup. You'll be fine. Okay, so here's what you'll be greeted with. Now, your Solution Explorer, which is the list of all the files in the project, may be over here on the right-hand side. I have moved mine to the left-hand side, and I've also configured mine to dark mode because I'm not a monster. So make sure you click dark mode. So this is what you have. Now we will go back. Let me see if I can move this over to the other side of the screen. So just for now, I'm going to make that go over here. Okay. So this is Visual Studio over here. I've just moved it to the right, and these are my instructions. So in Visual Studio, click OK to any warnings or dialog boxes that might show up if it's the first time you've launched Visual Studio. In Visual Studio, switch from debug mode to release mode. So there are two modes that you can compile this assignment in, debug mode and release mode. And so debug mode is a slower mode that you can use if you actually want to step through and do some visual debugging. I may show a little bit of that later with the assignment. I may not, depending on how much time we have. So just click on release mode. Over here, we have the solution platforms. So you may see x64, you may see x86. x86 is the 32-bit compiler version for Visual Studio. In this course, we are going to strictly be using the x64 version. And in fact, what I'm going to do before I release the assignment file is I'm going to remove the x86 version from this, just so you don't make any mistakes. So make sure you are on release and you are on x64. And so debug mode is useful for debugging, but it is much slower than release mode. Then right-click the SFML game project and click Build. And so this, of course, means the A1 Tron project. So right-click and Build. And then down here in our Build window, you will see the output for that. So let's see what the Build window says. This is going to be a little bit small. So you should get no errors and no warnings if everything was successful. So we see down here, build, 1 succeeded, 0 failed, 0 up to date, and 0 skipped. So these numbers down here correspond to the number of projects in the solution file. So when I clicked build, one of my project builds was successful, and then none of them had any problems. Okay, so that produced an executable file. And if everything was successful, no error should pop up. And to compile and run in one click, click the local Windows debugger at the top of Visual Studio. Before I do that, what I want to show you is what compiling that did is if I go to the bin folder in the assignment. So if I come back here, now I'm going to tell you what all these files are. The assignment zip file has a README file. That's the explanation of the assignment, which we'll go over in a bit. It gives you a marking scheme file, which is how you get your marks. It gives you a make file, which you can use in Windows or Linux or Mac to actually just type make to compile your program. There is a Visual Studio folder, which contains all of the Visual Studio project files, as well as the intermediate build files that, like the objects for each of the things, they're all in this x64 folder. We don't really need to worry about those. The source folder contains all of the source code for this assignment, and the bin folder contains, that's the output folder. It contains all the things like our fonts, our configuration, and our output executable file. So if we run the output executable here, oh look, we're playing Tron. That's great. This is our assignment. The build worked. However, it's going to be kind of annoying to right-click, build, and then run the game every time. So what you can do in order to build and run your game, your assignment, in one click, is you just click local Windows debugger. If it's not built, it will build it for you. If it is built, you see it's running, right? So it runs right there. Okay, the last thing I will mention about the instructions is that there are 2 common errors that you will see in Windows if you did something wrong. So if it says that sfml/graphics.hpp was not found when you go to compile down here, it means that you did not do step 4 correctly. Okay, so it means that you didn't do, if it says the HPP file was not found, then this means that Visual Studio cannot see the environment variable. So either you typed this wrong, or you typed this wrong, or you did not restart Visual Studio. One of these 3 things is the error. Every year I get about 5 to 10 people in the class who have this error. Trust me, you made a typo. Okay? I have never had, so I had one student ever who had a legitimate problem, and that legitimate problem was that their RAM was faulty. Okay? Like, that's the only thing that we could figure out was wrong, because everything was right, and then other programs started crashing. He had to get a new laptop. So as long as your hardware is okay, I am 100% sure that these instructions work. All right? If it says that when you go to run the program, if it says, oh, I couldn't find this DLL file in a pop-up window, it means that you didn't do the second part of this properly, where you set the path to show SFML dir/bin. Okay? So if you do step 4 correctly, everything should work. There you go. All right, so now we have Visual Studio all set up with our project, and now we can start programming. So that's it for the virtual machine. So I'm going to close down the virtual machine because it's a bit slow, and I'm going to pop over here to our actual real desktop machine where I have Visual Studio open with the actual project files in the background. So if I click run local debugger, it will compile everything for me, and it will run the Tron game. Perfect. Now I should have a little option down here to click this to maximize the Tron. Perfect. All right. So whenever I run this, it's not actually full screen. This is this is what it actually looks like, right? This is how small the window is for the game on my screen, and that's how, my monitor is 1440p, so it takes up exactly 1/4 of the screen. But I can have this option here just for the stream to maximize that so you can see it running a bit easier. Okay, so what I am going to do now, and what you should do first when you get the assignment, is actually, let's go over, I'll run the game and I'll explain things a little bit, and then I'll read the README file. So let's run this, and you can see here, okay, what is happening here? Well, this game, and one second. If I make this a bit smaller, you can see here, so there's two parts to this user interface. I've given you a user interface. Over on the left is this grid where the Tron battle actually takes place. Over on the right is a list of players with different colors and scores. Okay, so in the game of Tron, let's see if this magic works. All right, so this is my fancy blackboard setup. In the game of Tron, here is what happens. You start as a single pixel in this grid, or a single cell in the grid. And then what happens is, depending on which direction your Tron cycle, these are called Tron cycles, because if you ever watch the actual movie Tron, they're actually riding on motorcycles when they do this. So the Tron cycle is heading in a specific direction. So at every time step of the game, so let's say I have yellow over here and red over here. So at every time cycle, let's say red is moving to the right and yellow is moving down. So every time step of the game, you move and you occupy one more grid space. So red is going to move to the right and yellow is going to move down. And then red is going to move to the right and yellow is going to move down. So let's say at this point, I hit the down arrow, or I choose to go down, then the next place red will occupy is here. And if I chose to move left, then the next place that yellow will occupy is right here. So let's say they continue to move like this. So yellow moves left, red moves down, yellow moves left, red moves down. We keep going, red moves down. Here we go. Red moves down, yellow moves over, and then red moves down, and then yellow, So here, if yellow chooses to go up, then it will be safe. If yellow chooses to go down, it will be safe. Yellow cannot choose to go right because it will run into itself and crash. And yellow, if it chooses to go left, will run into red and crash. So the whole point of Tron is to try and block your opponent off so they can no longer move. So here, if yellow had chosen to go to the left, then that Tron cycle will no longer be active and they will have died, essentially. Okay? So that's the game of Tron. At every time step of the game, every player in the game chooses to go up, down, left, or right. If they run into a wall or they run into an occupied cell, then they die. And their score is equivalent to the number of grid cells that they occupied during the game. So here, yellow would have a score of 1, 2, 3, 4, 5, 6, 7, 8. And red would have a score of 9. And so as soon as n-1 of the players have died, then the game is over. And then the last person standing has the highest score. And so that's what your goal is to stay alive for as long as possible in the game of Tron. Okay, so the second thing that I will show is that we are using a grid world for this assignment. And so at any time during the assignment, you are living in this grid, right? And this grid and all of the SFML coordinate space starts at, let me type in white here if I can. So you do have this grid, and 0, 0 is in the top left corner. The width of the screen, let's just call that W. And so we have, this is W in the X direction and 0 in the Y direction, right? Down here, this is going to be 0 in the X direction and height in the Y direction. And down here, this is going to be W in the width direction and height in the y direction. And so 0, 0 in SFML and in our game space starts in the top left. All right. And then it grows downward, positive in y, and it grows positive in x to the right. Okay. So for this game, you are going to be dealing with starting in 0, 0. So for example, this place right here on the map, this would be location 0, 1, 2, 3 and 0, 1, 2, 3. And so let's just do this one. So the XY location of this one is 0, 1, 2, 3, 4, 5 in the X direction and 0, 1, 2, 3 in the Y direction. So this is cell row 5, column 3. Okay? That's how you read the coordinate space for this. All right. And so, sorry, that's not row 5, column 3. Because rows and columns are not X and Y, they are Y and X. So this is row 3, column 5. Okay? So depending on whether or not you were asked for X or Y or row or column, you have to swap those values, of course. Okay, so that's the rules for Tron. And then if we go back here to our actual Tron game, and I'm going to maximize this now, inside our user interface, we have 4 players. And so those 4 players are going to implement some sort of AI to control themselves within this grid world. And so essentially what we have here are 4 different players. One of them is your assignment. And so that says group name up here. The other one says random. My face is just in the way right now. I don't want to have to go through the trouble of moving that because I have it locked into place in a specific way. So we have the red player, which actually does nothing. It just goes up into the ceiling and dies. Yellow actually takes completely random actions. It just chooses a random direction on each time step. And then there's 2 other players here, which I'll explain in a bit. But essentially, this is what happens. And so you can see here that green, which is this thing called go straight, which it just goes straight until it hits something, does fairly well. Okay, so you can see here, oh wow, okay, so go straight did really well until it killed itself there. So each of these is an AI controlling Tron, and basically just at each time step, the whole job of the AI is to decide whether or not I want to go up, down, left, or right on the next time step. That's it. That is assignment 1 done, right? Okay, so no, I'm going to show you a bunch more stuff about the assignment. Okie doke. So over here, the assignment structure has several files in it. I hope you are familiar with C++ or you have watched the lectures on C++ and you know the difference between like a header file now and a CPP implementation file. So over here, we have 1, 2, 3, 4 different classes that I've included and a main file as well. So the main program just sets up a Tron GUI class with a config file and then says run. That's it. That's all the main function does. Every C++ class or every C++ program needs a main function. And so what is this Tron GUI that I've done? Well, the Tron GUI is something that you do not need to necessarily concern yourself with for this assignment. So the Tron GUI has a bunch of code in it. It's about 100 lines of code. And what the Tron GUI does is it's all the code using SFML to actually draw this user interface. And it also does, when I hit the R key, it restarts the game. Okay, so that's what the Tron GUI class does. You do not need to know what that is doing whatsoever, other than to know that it is running at, let's see here, it is running at 60 frames per second, and before it draws every frame of the game, it asks your AI what direction you want to go through, what direction you want to go in for this time step. So every single time step, so 60 times per second, the Tron GUI will ask your AI, what direction do you want to go in? It will then update the level to indicate that you've moved up, down, left, or right, and then it will draw the result of that movement. And so it'll just do that 60 times per second. If you want that to slow down, so if your game is moving a bit too fast, let me just see here. Have I included? No. Okay. So I haven't included any way to set that slower, but if I did say set this to 5 frames per second and run it again, then this will now be running at 5 frames per second, right? And so you can see how that is a bit easier to digest while you're debugging, maybe. Okay. So that is what the GUI does. If you want to, you can read through this code, but do not modify that code for your final submission. Okay, you're only submitting one file for this assignment, so none of the changes you make to this code will be submitted anyway. Next, we have the Tron Battle class. So the Tron Battle class is essentially the class that holds all the data for a particular battle, right? So the battle is essentially the width and height of the level, of the grid. This level here contains all the data about what is on the grid. So if I go back to my Blackboard here, this is essentially the level variable, all right? So the level variable is a vector of vectors. It's essentially a big 2D array, okay? And so the vector of vectors, essentially, what it stores is if there is nothing in a grid cell, it stores a -1. So for all of these up here, it would store -1, -1, -1. So if it's black, it stores a -1. Otherwise, it stores the ID of the player that occupies that cell. And the ID of the player is going to be an integer representing that player. So like the first player will be 0, the second player will be 1, the third player will be 2. You can have any number of players. Every time a player is added to the game engine gives them a unique integer identifier. So this grid that's in the Tron battle, the 2D vector essentially, just stores an integer to represent what is on the map. So if there's nothing there, it's a -1. Otherwise, it's a positive integer representing the player's identification. So that's what that does. Then there is a vector of AI objects, and those AI objects are going to be the decision making that you will have to write for this assignment. And then there is a vector of cycle objects. So the cycles are the things which actually contain some information like where is this cycle right now? Because if we go back to the Blackboard, as your Tron cycle is moving around, this, for example, you don't know exactly where the head of this thing is. So right here, your Tron cycle has 2 components to it, essentially. All of the grid cells that it currently occupies, and currently where the head of the light cycle is. And so this Tron cycle object over here contains the following information. It contains the unique integer identifier for that Tron cycle. So that is what the level file stores when it moves around. It contains the X and Y position of the Tron light cycle. So that means where the head of the light cycle is. So for the red cycle, that would be 0, 1, 2, 3, 4, 5 in the X direction, and 0, 1, 2, 3, 4, 5, 6 in the Y direction. So this Tron cycle would currently store 5, 6 as its position. So that is the position of the head of the cycle. It also stores a direction. And so the direction is the last direction that it moved. Okay. So the direction, for example, if this moved down on the last time step, then the direction would be down. Right? Or if it moved left on the last time step, like yellow, then the direction that it held would be left. Now, the reason that you may want to have the direction there is for, hey, if I just want to go straight, then all I need to do is go in the direction that I went on the last time step. So it's nice to know sort of where you came from on the last time step. It will also store a color. So that color is what gets drawn to the screen, and that is just an RGB 0 to 255 SFML color. It also has a score. So if I run this program, you can see over here that every time each light cycle moves, the score goes up by 1. And so that score is stored in the Tron cycle object. And down here, we have one more thing, which is whether or not the Tron cycle has died, right? So if this alive variable is true, then the Tron cycle is still alive and it's still moving. So down here, these are all private variables, of course. And so down here, I have a bunch of public functions to get access to that data, proper object-oriented programming, etc. So that's the Tron cycle class. And the very last thing is the Tron AI class. And so what I've done here is, in order to implement brains for all of these Tron cycles, each Tron cycle, so if I go to Tron battle, you see here that there's one vector of cycles and one vector of AIs. And so what happens here is, in the little game engine that I've set up, every time step, if your Tron cycle lives at a particular index in this vector. So for example, if we have cycles 0, that is controlled by AIs 0. Cycles 2 is controlled by AIs 2. All right, so that's the way it works. I have one vector of cycles and one vector of AIs. And so Tron cycle 0, 1, 2, 3, 4, 5, 6 are controlled respectively by AIs 0, 1, 2, 3, 4, 5, 6. This Tron AI object, the reason I'm storing a pointer to that is because Tron AI is a base class. So I have a base class of Tron AI, and then I have a number of different AIs that inherit from that base class. So these are derived classes from Tron AI. And so you can see here that Tron AI student, which is your class, is going to be a public Tron AI, and that's just the way of doing inheritance in C++. So I have Tron student here, Tron random, Tron AI random safe, Tron AI go straight. And I also have a function here which lets me get Tron AIs by name. That's just for the user interface. I'll go over that in a little bit. But essentially, the Tron AI class has one private variable by default. That is this here. It is just default. Okay. In the config file, we give names to things, and then those names are what show up here inside this. So random safe, random straight, go straight, whatever, that is where that name variable ends up appearing. So that's what that is. Each Tron AI has to have a constructor. It has a function to return the name, and then it has a function called getAction. So getAction is the function that you have to implement for this assignment, and it takes in a Tron battle object, a const Tron battle object, so that you cannot modify it, and it takes in a Tron cycle as well. So essentially, what you are given is, it says, okay, here is the current state of the Tron battle. You are the red snake, right? You are the red cycle. Tell me what direction you want to go in, right? So that is the, what's that function called? It is called getAction. So the getAction function says, you are the red cycle. Here's the current board. Give me what action you want to do at this time step, whether or not go up, down, left, or right. And that's it. That's all you have to do for this assignment, is implement this Tron AI function. So let's go over the README file now for the assignment, and we'll see exactly how we do that. Okie doke. So this is COMP4303, assignment number 1. For this assignment, you will submit only one file. That is source/tronai.cpp. So any changes that you make to any other file will not be in this, will not be included in the submission. Okay, you are only making changes to tronai.cpp. As you should only be modifying this file for the assignment. If you submit any additional files, this will result in a loss of marks. And in fact, I'm going to set up the Dropbox so that you are only allowed to submit one file, and it has to be a CPP file. You must include the following info in a comment at the top of the file. All of the students' names, CS usernames, meaning like your whatever at mon.ca, and student numbers. And if you didn't get a specific feature to work, please explain what you tried to do to get it work, and partial marks may be given for effort. The program specification. In this assignment, you will be writing an AI for the game of Tron, the game that I've just explained. You will only need to modify the Tron AI student getAction function, which is within source/tronai.cpp. Your function is going to return an unsigned integer, or a size type in C++, corresponding to the index of the action to be taken in the m directions vector defined in tronbattle.h. So this is basically the most complex part of this assignment, is understanding this part. So let's go back to the blackboard at first. Let's say that my player is currently right here in the level. It has to decide whether or not it wants to go up. That's a bit small. So does it want to go up, down, left, or right? Okay. So what we have in our code, we have a direction object. That direction object, so a direction, contains an x and a y, and that is the change in x and the change in y for movement, right? So if you did 3200, you should be very familiar with this by now. So for example, left is going, let me move this over so it's, have a bit more room to type here. So left would be -1 in the y and 0, or say -1 in the x and 0 in the y direction. Right would be 1 in the x and 0 in the y. Up would be 0 in the x and -1 in the y. And down would be 0 in the x and 1 in the y. So what I have here, if we go back to our code, is over in Tron Battle, I have this directions vector, right? So the directions vector is, this is up, this is down, this is left, and this is right. And if we look at Tron AI, the getAction function returns a size t, which is essentially an unsigned integer, which is an index into this. Okay? So if you want to return the action of going down, you would return the integer 1, because it's 0, 1, 2, 3. If you want to go right, you will return the integer 3. If you want to go up, you return 0. If you want to return left, if you want to go left, you return 2. Okay? Now, why did I do it that way? It was because I didn't want arbitrary directions to be able to be returned by this. So here we have the direction struct. So a struct is a very, very simple class with all private variables. So you can see here that our directions have an integer x and an integer y. Okay, so what that means then is that we have this legal actions vector, and whenever you want to return an action from this function, all you have to do is return an index into that vector. So in your function, if you want to look at it this way, all you are ever doing is returning 0, 1, 2, or 3, which is corresponding to these actions. So directions are stored in a struct with an x and a y variable denoting the change in x in y if that direction is chosen to move. For example, moving right is a shift of 1 in the x direction and 0 in the y direction. So the resulting direction is 1, 0. In this environment, y increases in the downward direction, so the down direction will be 0, 1. Example usage of direction can be seen in the example AIs in tronai.cpp, and I'll go over that in a second. So some miscellaneous stuff. The R key restarts the level, and the escape key closes the game. So the there is a configuration file for this assignment. The configuration file will specify the level size as well as the properties of each of the players in the game. The first line of the file has the following format, while the player line syntax follows afterwards. So what does this mean? It means that if I go over here to my assignment files, I go into the bin directory, I am going to have a config.txt. Okay, so here is the config.txt file. I'll make this a little bit smaller so we can go over it while I have this open. So the config essentially sets up the starting positions of all the different cycles in the game. So the first line denotes the size of the map. Okay, so this is just width, height, and that is the size of the Tron playing area. So that's the very first thing. And then each of these defines, it's a player. Here's the name of the player. Here is the starting X and Y of that player. And here is the R, G, and B of that player. So if I have this open over here and I run my game, I'm going to see that I have 4 players with, so one is called, so one is not, oh, sorry, this is not the name of the player. This is the name of the class, okay? So one of them is in the top left and it's red. So here we have 3-3 red, that is that player. The green player is this one, that is the go straight player. And the random safe player is over here, that is the blue player. So you can see that all of these match up. If I, for example, take the go straight player out of this config file and then rerun the program, I no longer have that player down here, right? So you can modify this and rerun it and it'll just work. So that is already, that's done for you by the program. Please do not change that in any way, shape, or form. All right. So the last thing I want to show you is the sample AIs that I've included. So here we've seen that there are a number of different sample AI classes. Each of them essentially just have to implement this get action function. Over here, we see that Tron AI student, it says replace group name with your group's last name. So for example, if my group partner's name was Smith, then you can just go and say alphabetical order and it will be Churchill Smith. And that will be what shows up when we run the competition. And then you have to implement this function, which takes in a battle and a cycle and returns the index of the direction. Okay? So here I'm just returning 0. So what happens to the student player currently? If I run it, you'll see 0 is up. And so this player just goes up. That's it. So Churchill Smith over here just moved up and died immediately. So that's because every single time step, I'm just moving up. So let's look at some of the sample AIs so you can get an idea of how to actually use this interface, because it's been a little bit complicated so far, but trust me, it's really easy to use. So at some point, you have to know what legal actions there are. So this is the Tron AI random player. How did the random player take an action? Okay, well, if we look here, we see that the first thing it does is calls the battle.getLegalActions function. So what does that do? Well, that will return a vector of action indices of all the legal actions, right? And so all we have to do then to select a random action is look at the size of that vector, which is right here, generate a random number and mod it with that size, right? And I went over how to generate random numbers in C++ in the lectures that are available to you from 4300. I believe I did. I think so. And so this rand function returns a random integer. We mod it with the legal action size. And so this gives us a random index into this vector. And so all I have to do to choose a legal action is return a random index from that legal actions vector. So you see how that works? Why it's really nice to have this index rather than just a vector of actions. So what does this legal actions thing do? Well, we can go over here and we can look. So I'm going to look and I'm going to say, okay, get legal actions. What does that do? Well, it says I'm going to set up a vector of all the legal actions, and initially that's going to be blank. And it says for each action, so the number of actions is 4, right? Because I'm going to have 4 possible actions that I can do. If that action is legal, then add it to the legal actions. Okay, okay, Dave, you went through all the actions. You said you saw if they were legal, etc. What is a legal action? So a legal action here is essentially, it's not a legal action if it goes backward onto itself, okay? So that means that right here, for the red player here, if the red player is right here, and it has come downward, pretty obviously, then the only legal actions for this red player are to move left, to move right, or to move down. Okay, so that's what get legal actions does, is it says, what are the directions that you can legally move in? Now, I believe if you move up here, if you actually choose to move up, you'll just die, so don't do that. So get legal actions will get you the 3 directions that you can move in without immediately moving backward into yourself. It does not guarantee that those places are actually safe to move to. So for example here, you would say, okay, these 3 are still the legal actions, but if you chose right or if you chose down, you would immediately run into a wall or another player or something. So just realize it's legality, it's not safety. So if we go back over here to Tron AI, then that's all that the random player is doing, is it's getting a vector of all the legal actions and choosing a random one from that vector. So pretty simple way of going through all the actions. Next, let's show you how to actually try and do something that's a little bit safer than random. So this is called random safe. And what this will do is it's going to iterate through all the legal actions and choose a safe action, which means that if there is a direction that I can go in that is not going to immediately die, then go there. So for example, if we had this scenario with red, the legal actions are left, down, and right, but we can see here that right is currently occupied by something. So that is not what I'm calling a safe action, because I'll die if I choose right. So what this function is going to do is it's going to build a vector of the safe actions, which would be left and down, and then it is going to choose a random one of those to pick, right? Now, here's a situation you're going to run into sometimes. Maybe we have a situation like this, right? So as a human, you can tell that moving left, that is not a good move because you are going to trap yourself in here, right? So moving left is still considered a safe action for the purposes of this function because it is immediately safe. I'm not looking down here to say, okay, like how many tiles can I fill? How open is it, etc. As a human, you could say, well, okay, moving down is probably the way to go here because I'm going to die immediately if I go right. I'm going to die soon if I go to the left. So let's go down to give myself the most options, right? But let's not get ahead of ourselves yet. We're just talking about the actual legal actions. Safe actions, sorry. So here, what this function does is it's going to create a vector called safe actions. And again, we are storing actions by their index. So 0's up, 1 is down, etc. So I'm going to go through each action in my legal actions from the battle. And so that gets the cycle, looks at the cycle, looks around it, gets all the legal actions. Now I'm going to calculate the position of the next cycle, of the cycle if it took that next action, right? So what this means is that this is the direction. So battle.getDirection action. If I want to know, based on this action, what is the X and Y change of that action, then I have this is the index. Remember that, okay? So in here, I am not putting in a new vector of like up equals 0, -1, etc. In order to get the actual directions, meaning the change in X, Y of the action, I will call battle.getDirection. So if this is up, then this dir is going to have X value 0 and Y value -1. So I ask the battle, what is the direction of this action? And then I'm going to calculate where I would be if I took that action. So here on the blackboard, if I take action left, well, that's going to be -1 in the X and +0 in the Y. And so this is where I would be if I took the action left. So that's what that function is going to, this is what this is computing. So I compute the new X and the new Y. Now, in the battle class, if I go over to Tron battle, I have this function which is called isSafe. Okay, so Tron battle, if I look at the isSafe function, isSafe does the following calculation. It checks if the location is within the bounds of the level. So is the new x greater than 0, greater than or equal to 0, and less than level that size? So the very first check is to see whether or not we might be going over to the left and we might be going over to the right. So if my cycle is here, moving left is not a safe action because I'll die if I move into the left-hand side. Similarly, it's going to check going up or down to see if that is still within the bounds of the level. So here going up is not safe. And then what it's going to do is it's going to check to see if the level has a -1. So if we go back to the code, after we've checked the X and the Y for safety, it asks, hey, is the level at location X, Y equal to -1? If all of those things are true, then that is a safe position to be at. Okay, so if we go back to our Tron AI, we're going to say if battle.isSafe, new X, new Y, then safe actions.pushback action. So this is actually something that you are probably going to be doing in your code, right? Because the very first thing that you should do is create a vector of safe actions. And I don't mind if you copy and paste this because, I mean, you're just going to retype it anyway. So the very first thing you should do is create the vector of safe actions, right? Because you only want to choose from the safe actions. You never want to take an unsafe action. So essentially, if we couldn't find any safe actions, then I don't care which direction I go. So I'm just going to return the previous direction that I was going in. So I'm just going to continue going straight into the wall. Otherwise, if I did find some safe actions, then this returns a random one of those safe actions. So random safe, this AI is exactly what you think it would do. It would look at all the safe actions and choose a random one from it. Now, sometimes, as I said before, random safe will kind of paint its way into a corner. So it might go left here, and then it would go up, and now it's stuck. There are no more legal actions, so it would go up again, and it would just run into the wall, and it would die. Okay? Next is we have go straight. So what go straight does is it keeps going in the same direction, which means go straight. And then if it sees that it would run into a wall, if it went in that direction, it chooses a random safe direction to go in. So this is actually pretty cool. You might think that that's a lot of code, but it's not. So the direction that we are currently heading, we can get that by saying cycle.dir, right? That's the direction that we went last time. And so we calculate where we would be if we kept going in that direction. If that is a safe location, then just return that direction. So if I'm going left, if I went left last time, keep going left, see where I'm going to be if I keep going left, and if it's safe, then keep going left, right? Otherwise, I want to go in a random safe direction. So here's what's sort of happened at this point. Let's say that, I can't go back any further. So let's say that I am yellow over here, and yellow has gone left all the way until it gets to here. So I have just keep going straight, and now it says, uh-oh, what are my safe directions? So it's going to look and it's going to know that it's not safe to go left, so now I want to take a random safe action, right? So I can go up or I can go down. So it's going to keep going the same direction until it's about to hit something, then it will take a random turn in a safe direction. And so you might think that I have to, redo all of this code. But the cool thing is that these AIs are actually modular, right? So I can actually say, create a random safe Tron AI and get the action that it would do. So I don't need to retype all of this stuff. You see how cool that is? So this random safe, that is the exact behavior that we want to. Oh, sorry, I'm not looking at the code here. So let me rewind a little bit. Something I've already said. So it basically says, if I've kept going straight and it is safe, just keep going straight if it is safe. Otherwise, you might think that I would have to retype all of this code about figuring out safe actions, etc., but I don't. What I can do is I actually want to completely replicate the behavior of the random safe. And so here, I just create a random safe AI and ask what it would do. See that? So that's pretty cool. So it essentially says, if I'm in this situation, if I can keep going to the left, keep going left. Otherwise, ask the random safe AI what it would do. And it would look up, or it would look around and say, okay, take a random action between up and down. Now, you don't have to do that in your code. That's fine. I just wanted to show how that worked. And the very last thing in this function, you do not need to worry about this, but this is just the code that lets my user interface get things from strings. Okay, so it says, hey, in the config file, if it says student, then return a neutron AI student. If it says random, return a neutron AI random, etc., etc. Okay, so you don't need to worry about this function. That is used for the user interface. And that's it. So your entire thing for this assignment is to implement this function here, right? Is you have to change this to your group name, and then you have to implement this function, which does something clever. Now, what do I mean by something clever? That's always a little bit of a point of contention. So what I mean is your AI that you create should pretty much, like the very bottom baseline, is that it should always beat the AIs that I have given to you. Okay, so these AIs are super dumb, right? Super, super, super dumb. Your AI should always beat them. Now, okay, it's possible to lose to something that does random, right? Because maybe the random thing just gets the God seed and destroys you. But your AI should do something pretty cool. Now, what does that mean by pretty cool? Well, let's go to this situation again where we're down here, right? So we're in this situation, and we want to know what action should I take here. So I can't go up. If I go right, I should die. Should I go left or should I go down? A lot of the time in Tron, you often want to know this concept of like, how many free spaces are there in this blocked off area, right? So how many free spaces are there here? Well, there's 3. How would I compute that? Maybe I would have to do something like a breadth first search to know that. So one possible way that you can do something like this is you can say, look at the direction that I should head in, do a breadth first search, and count the number of things that my breadth first search was able to touch. That will give me like a 3 here. Why is that font so small? That's really strange. It'll give me like a 3 here. It'll give me like 100 here or something. Another thing that you could do, which is maybe a bit simpler, is say, look in these directions and count how many spaces until I hit a wall if I keep going straight, right? So I look down and say, oh, look, I have 3 spaces here before I would hit a wall. I have 1 space here before I would hit a wall. So maybe go down instead of going left, right? Now, that's not quite as good as the BFS, but it will be a lot faster. You can take some like aggressive strategies where you might want to choose direction, like the direction that maybe heads toward the other player's, the head of that cycle. So you can get access to that data if you want, in order to try and trap them or something like that. Another thing you could do is maybe try and like section off a part of the screen and then do the snake strategy where you sort of like go, you know, down and over, down and over, down and over, and then just like fill this up. Right? That might be a strategy. So your goal is to live as long as possible. And basically what I want you to do is something kind of clever. Just come up with something clever for this. And we will be talking about grids and stuff in the next couple of lectures. So obviously you don't have to do this tonight, but over the next couple of lectures, get some ideas for something clever. And then I will be having an in-class competition where I'm going to do battle between all the AIs. All right. So if we come back here to the README file, so marking will be pretty lenient for this assignment. You must do something significantly different from the examples. And here's a little, this part's a little bit spicy, okay? A little bit spicy. You will get a maximum of 95% in this assignment unless you get 8th place or higher in the in-class competition. So we got about 40 people in the class, so about half of the class is going to cap out at 95% here, okay? So 95% is fine, but it means that we're sort of competing for those marks, okay? If you really have a strong opposition to this, maybe I'll change that. But I like to just give a little, a little kick in the bum. Maybe I'll change this to 98 or something like that, so it doesn't really affect your grade. But, I want the people who really tried at this assignment to get the full marks. But you can get at least a 95 just by doing something clever, even if you come last in the competition. And so in order to get full marks, you must beat the sample AIs the vast majority of the time, okay? So the last thing I'll look at is the marking scheme for the assignment. So if we come over here, we have a marking scheme. We have up to 5% of our assignments for code, style, modularity, readability. If you've done any course with me, you know all about that already. I like your code to be neat and tidy. The Tron AI system is worth 50%. So did you do something interesting? You can't just copy an existing system. And AI performance, it must beat the AIs that I gave you the majority of the time. And the class competition is worth up to 5% for the top 8 finishers. And you can get up to 10% bonus stuff if you did something really, really cool. Okay, so if you went above and beyond and did some crazy like depth first search AI system, then you can get bonus marks. So this is not true. I am going to have the following. I did not say this yet, but I will post this on D2L. You will get minus 5% for every hour the assignment is late. This is rounded up. So if your assignment is, all assignments will be due at 11:59 p.m. If your assignment is 1 minute late, that is 5% off. If your assignment is 59 minutes late, that is, oh, sorry. Did I say that correctly? I can't remember what I said, but if it's 1 minute late, it's 5% off. If it is every amount of minutes up to 1 hour late is 5% off. Every additional hour, so if you are 1 hour and 1 minute late, that is 10% off. Okay? So, okay. Must submit a single file. And so if you submit that's not even relevant because I won't allow you to submit another file. Okay. So someone had a good question. So just realize that you will be penalized for submitting something late. Someone said, do we have any time constraints? Very, very good question. Thank you for asking that. Yes. So in the competition, I want at most, your AI should be like half a second. Okay. Now a BFS on like 100 nodes should take like less than 1/10 of a millisecond. It should be really, really, really fast, right? So I'm going to give you like up to, let's say, half a second to do your calculation. You shouldn't be coming anywhere close to that amount of time. If you are running your code and it's very, very slow, make sure that you have it in release mode and not debug mode. That's probably why it's running so slow. All right, so good question. Up to half a second, but it should not be anywhere close to that, that amount. All right, so that's it. That's it for the assignment. All you got to do is implement this function. Just do something clever. And then for the remainder of the assignments, assignment 2 and assignment 3 are going to follow that exact same syntax. Or sorry, not syntax. They're going to follow the exact same structure for the assignments, okay? We're going to have like a Visual Studio project file. We're going to have one file that you edit and the rest of them do other things, and then you'll submit it on D2L. So I don't need to go over all of this setup instructions for any of the remaining assignments because they'll all follow the same thing. And of course, if you are on a Mac or you are using Linux, then all you would do is open up this file in a text editor, and then you can use the makefile or the single line command to compile. You wouldn't be using Visual Studio like this, but you could set up VS Code to use to edit your files for you. All right, that's it. I don't see any more questions out there. So that's it for assignment 1. It will be released by midnight tonight. And so I hope you have a great day, and I'll see you in the next lecture.